Hi, physicists. We're going to talk about collision basics. This is the equation for momentum. P equals mv. That is, the momentum is equal to the mass times velocity. Mass is in kilograms, velocity meters per second. So we end up with a unit for momentum of kilogram meters per second. Three types of collisions that we need to be aware of: explosive, elastic, and inelastic. Explosion or explosive is when the two objects start together and then separate, like two ice skaters pushing off of each other, or literally an explosion, a firecracker. Elastic is when one object comes in, hits another object, and they bounce off of each other. Elastic. Inelastic, same situation, except the two objects don't bounce off of each other, they stick together. The big picture is conservation of momentum. That is, the total momentum before the collision must be equal to the total momentum after the collision. Momentum is conserved. So let's take a look at an example of elastic collision. Here, one ball comes in, the green ball in the image comes in and hits the blue ball, and they don't stick together. They bounce off of each other. That is elastic. The equation for this type of collision would be written out like this. And this looks like a lot, but really, m1v1i is the momentum of the first ball. m2v2i is the momentum of the second ball. And the subscript i's are initial. On the other side of the equation, the subscript f's are the final. So this really just says the two momentums added up before collision must be equal to the two momentums added up after collision. Inelastic would look like this. The two momentums added up before the collision are equal to, in this right-hand side, the two masses are added together to act like one single mass because they stick together. So those two masses added get multiplied by some final velocity that is the final velocity for the joined masses. And finally, in an explosive collision, we start typically with the objects not moving before they explode apart. So this doesn't have to be the case, but almost always, at least in this class, we're going to start with an explosive collision with a momentum of 0. That is, the objects aren't moving, but then when they explode apart, one will go left, one will go right. Let's take a look at an example. A football player with mass 72 kilograms is running 7 meters per second when they collide with a stationary 8-kilogram player. What is their combined velocity immediately after the collision? One of the first things you want to think about, in addition to writing down givens, unknowns, is what type of collision is this? Two objects separate at first, and then at the end, they are combined into one mass. So that is inelastic. They stick together. So we're going to use the inelastic collision equation where the two separate momentums added together are equal to one combined momentum in the end. Write down some givens. We know the masses of the two football players. We know the velocities of the two football players. The thing we don't know, the unknown, is the final velocity of the combined players. Substituting in, we have a fairly nice equation, just a little bit of algebra to do. Simplify the left-hand side, simplify the 72 plus 80 and divide, and you'll solve for the final velocity. We should get 3.3 meters per second. Quick summary. Momentum is mass times velocity. There are three major types of collisions that we talk about: explosive, elastic, and inelastic. And when we analyze problems with momentum, it's important that we assume conservation of momentum. That is, the total momentum before the collision is equal to the total momentum after the collision.